Okay, so we are at the start times. So let's get started. So we discussed the mesh current analysis basic uh, theory during the last lecture. At the end of the last lecture, essentially you will look for meshes within a circuit and then apply the KVL. Hello, Drew. How are you? So, I just got started. Essentially, we talked about the mesh current analysis in our last lecture, and today we are gonna build on that foundation the last week that we discussed and solve some additional problems. Essentially, what you're going to do is you're going to look for meshes within your circuit, then apply KVL to those meshes and write the various voltages in terms of the currents. So again, it's going to be KVL and Ohm's law, and essentially you develop the equations, then solving for unknown values using the simultaneous set of equations, we can determine the unknown values. So let's look at a circuit. We talked about a general example during the last session. Today, I'm going to show you this example here. So these are the values of your resistors and the two voltage sources. So now we have to, using our convention, we will write the currents for the meshes. So this is my I1 and this is I2. As you notice, we are using the clockwise convention for this. So now for mesh number 1, I can write my equation. And you can label your voltages following the passive sign convention. Okay. So here the first mesh would give me minus 60 plus 4I1 plus 10 into I1 minus I2 plus I1, since it's 1. The sum of all these voltages would be equal to 0. Okay, so don't worry about the signs, they will take care of themselves at the end. For now, we'll just write all the quantities. So now I need to simplify this expression to bring the like terms together. Okay, so we see that we have 3 quantities with the I1. So we'll combine them, they're all positive. And then we have an I2, and the 60 is the negative number. So we'll use that in the next step to bring it to the other side, to bring it in the where we bring the constant quantities to the right hand side of the equal sign, and that's the general form of our expressions. So if I add these I1 quantities, it's going to be 15 I1 minus 10 I2 minus 60 is equal to 0, and then bringing it to the correct format, this is going to be my equation number 1. Okay, so that is the equation that I derived from mesh number 1. Okay, so now let's write the equation for mesh number 2. So now I apply the passive sign convention to this 10 ohm resistor in terms of the I2. So therefore, I will have 10 I2 minus I1 plus 2 I2 plus 20 plus 3 I2. All that, the sum of this is equal to 0. So now let's expand this. Okay, so let's combine these terms, the I2 terms. So I have 10 I2 plus 2 I2 plus 3 I2. So I have minus 10 I1 plus 15 I2 plus 20 is equal to 0, bringing it to the correct format. And this is going to be my equation number 2. Let me just make sure everything is correct. Okay, so now these are, this is the two equations. So we have now simultaneous equations. We can solve by substitution, or we can, so I'll show you both the techniques. So first I'll create the matrix if you want to solve it that way. So writing the coefficients. So now you can plug this into the calculator or in MATLAB and solve for the I1 and I2 quantities. And using I1 and I2, since you know the resistance values, you can find any unknown quantity within that circuit if it is given that way. Okay, but since we're going to be solving this using the substitution technique, let's go ahead and do that. So from equation number 1, I can get I can bring the equation in the format where I can find the value for I1. So let's just write it as is, and then we can work from there. So I1 minus 10 I2 is equal to 60. And then I brought the 10 I2 to the other side and became positive number. And I can solve for I1. I divide both hand side with 15. Okay, so you can call this equation number 3. Okay, so when you bring the one of the unknown quantities. When you derive that expression for it, you can call that equation number 3. Now I can plug in equation number 3 in equation number 2 to solve for I2. Okay, so we have minus 10, and I plug in this 10I2 plus 60 divided by 15, and the rest of the equation would be as is. So I have 15I2 equal to minus 20. Now, if I were to cancel out some terms, one thing you could do is, you can multiply both sides by 15 in order to cancel the denominator in 15, or you can normalize it in other way, which is just taking these fractional numbers. So if I did that, if I multiplied both end sides by 15, which means that it's not going to have any impact on the value of this expression, or if I went the other way, I'll end up with the same result. So let's go one more step. So 2 times 5. So the ratio of these two, 10 by 15, is same as ratio of 2 by 3. Okay, so that will make it a little bit easier to multiply 3 instead of 15. So now I want to go ahead and maybe take it as a common denominator. Okay. Okay, before I do that, I just don't want to skip the step so that there's no confusion. Let's go ahead and multiply the 2 there. So what we will have is 20I2 plus 120, and there's a negative sign here, and we have a 3 in the denominator, plus 15I2 is equal to minus 20. Okay. So now I took 3 as a common denominator from the left side of the equation, and then I apply the sign also. So I will have minus 20I2 minus 120 plus 45I2. Due to the common denominator, I multiplied 15 by the way, this is 15 by 3, and I got 45I2 is equal to minus 20. I do the cross multiplication, and I end up with minus 20I2 minus 120 plus 45I2 is equal to 3 times minus 20, and we end up with, again, we combine the 20I2 and 25I2, which one is a negative number, so I end up with the 25I2. So 45 minus 20 is 25, and I take the minus 120 to the other side, and if I take the multiplication of 3 by 20, it's going to be minus 60. So this 120 becomes a positive number, and then this one is 60 from 3 multiplied by minus 20, and I end up with 25I2 is equal to 60 and then I can solve for I2. So I2 is equal to 60 divided by 25, and I end up with 2.4 amperes as the answer there. Okay. Then I take this the quantity, the value of I2, and plug it into the equation that we have for I1, which is equation number 3. So equation number 3 and we know that I2 is 2.4 volts, 2.4 amperes. So I1 is 10 multiplied by 2.4 plus 60 divided by 15, and I can solve for I1. So I have 24 plus 60 divided by 15, and that equals to 84 divided by 15, and I have 5.6 amperes. Okay. So that's how you would solve for these two unknown quantities. So once I have I1 and I2, I should be able to find any quantity within that circuit. So I could find the voltages since I've given all the resistance values, and if there's any unknown quantity, I can find that. Okay. Any questions about how we solve this problem? Okay, so this is generally a standard type of problem that you will see where you will have two equations and two unknowns. You may see some problems with three equations and three unknowns. So maybe there's some problems will have a level of difficulty which is higher than this. Some problems will have a level of difficulty which is less than this. So again, any circuit that you see could be solved using either the node current node voltage, node current technique or the mesh voltage technique. So either of the two you can, I'm sorry, no, it's either the node voltage method or the mesh current method. So, but you have to determine which one is going to be easier to apply. And I'll show you one example where you can determine that one technique is simpler compared to the other one. And after that, I'll show you a little bit more complex example. So let's look at the simple one first. This one. So let's look at this circuit here. I have a voltage source here. Then I have a current source here. I have two resistors. And a voltage source here. So this is 15 ohms. This is 10 ohms, 20 volts, 2 amperes, and 25 volts. Okay, so now when you look at this circuit, you can think about, okay, can I use the mesh current analysis or node voltage analysis on this one? Which one will be easier? Again, the less the number of equations that you have, the simpler this solution is going to be. So if you have one equation and one unknown, it's going to be a lot easier compared to 2 or 3 equations and 2 or 3 unknowns. So if I were to apply the mesh current analysis on this, I will have to have 2 equations for I1 and I2, and then I'll have to solve for them and determine what the result is going to be, right? Now, the middle current is going to give you the difference of the two, right? So that makes it a little bit easier, but you still have two equations nonetheless. So now let's see what we are going to have if we were to apply the node voltage technique. If you were to apply the node voltage technique, we have to see how many nodes do we have, since we have seen that we have two meshes here. So I actually have four nodes here. So this is my node number 1, this is my node number 2, node number 3, and this is my node number 4. So this is 1, 2, 3, and 4. So if I look at the fourth node, that's an ideal candidate for the reference voltage or the reference node. So I'm just going to call it the reference node and assign a 0 voltage to that. Now I'm going to look for the node equations, but I have to see how many independent nodes do I have. So if I look at node number 1 and 3, I know the voltage is there. So at node number 1, the voltage is 20 volts. At node number 3, the voltage is 25 volts. So therefore, they're not independent nodes. The only node that is independent is node number 2. So that means that I only have to write one equation. So now if I compare this to the mesh current analysis, I had to write two equations. So it's simpler to solve it using the node voltage technique. So let's write the equation for node number 2. Okay, so if we have current going in this direction, and this current and the other one is already shown. So if I call this I1 and this one I2, the equation for this is going to be I1 plus 2 amperes minus I2 is equal to 0. Okay, and then we can write the equations. So the first equation is going to be 20 minus, let's just call it V sub 2 plus 2. I'm just going to get rid of the units there. And then minus V2 minus 25. By the way, there's a resistor value there, 15. And here I have the resistance of 10 ohms. And all this is equal to 0. Now, let's simplify this. Okay, so we can write this as 20 over 15. There are different ways you can do it. You can use the common denominator technique, or you can individually write each term, whatever you are comfortable with. Typically, I am comfortable writing the common denominator. It makes it a little bit easier for me to solve the problem, but it's entirely up to you how you solve it. So, but I'll show you this technique also. So here I have okay. So I bring the like terms together, and I have a negative sign there, and so I'm combining these two. Let me just we'll add that step there. So one thing we could do is we can write the fractional values, right? If you were to do the if you were to write the fractional values, you could write each of these terms. So 1 divided by 15 is 0.066, I believe, since we did it last time. But let me just go ahead and do it on the calculator. So it's going to be 0.067. I'll just write it as this, minus 0.067 V2. This one is minus 0.1 V2. 1 divided by 10 is 0.1. Then 20 divided by 15 is essentially 4 divided by 3. So let's do that. So it's 1.33. So I'm just going to write it 1.334 for this term, plus 2, and 25 is 2.5. 25 divided by 10 is 2.5, so I have 2.5. Then you can say it's minus 0.167 V sub 2. And then I add these three quantities. So I will get 5.834, okay, is equal to 0. By the way, this is also equal to 0. Got to write that there. And then we can say minus 0.167 V sub 2 is equal to minus 5.834. Two negative signs would cancel out with one another. So we have V2 is equal to 5.834 divided by 0.167. Okay, so this number if I do the calculation on this, 5.834 divided by 0.167 is 34.93 volts. Okay, so in this way you'd notice that I've had fewer equations, just one equation and one unknown, and you can solve for it using any technique that you're comfortable with. And that way you can write this voltage. Once you have this voltage, then you know the current source value is there, the resistance value is there, and then you have two other voltages. So using any one of those quantities, the known quantities, and you have the voltage at this node also, you can find any unknown values within that circuit, including power consumption or any voltages, so that can be used from this point on. Okay, so that's one of the other example where you have to determine which one is the best technique to solve this problem in fewer steps. So you can use either the node. So sometimes you may be asked to use either of the two techniques. In that case, you would have the freedom to use either technique, and regardless of which technique you use, you will end up with the same result. Okay, so that's one other example of how to approach these problems. Okay, any questions about this one? Okay, so let me show you one more example, and then we'll conclude this section of the chapter. So let's move on. Let's create some more space. This one will require some space. Okay, so I have this circuit which looks like this. There's only one source there. And this is a 100-volt voltage source. Then I have a 5 kilo ohm resistor here. I have a 10 kilo ohm resistor here. The 22 kilo ohm resistor here. 10K resistor here and 10K resistor here. Okay, so I'm asked to apply the mesh current analysis to solve this problem. So I will write the three meshes. You can label it however you like, but I just chose to write it like I1, I2, and I3. So for mesh number 1, if I write the equation for this, I will have 100 volts, and I'll just ignore the kilo ohms. So I'll just write it as 5, and later on when we are solving for it, we can bring it to the solution. So then I have plus 5 into I1 minus I3 plus 10 into I1 minus I2. Okay, and all this is equal to 0. So let's simplify this expression. I have 100 plus 5I1 minus 5I3 plus 10I1 minus 10I2 equal to 0. You bring it to the normal form where the constants are brought to the right hand side of the equal sign. So therefore, I'll combine the I1 terms and also shift the 100 to the other side. So if I combine the two I1s, I have 15 I1 there, and then minus 10 I2 minus 5 I3 equal to minus 100. Now this is my equation number 1. Okay, so you can write this like that. For mesh number 2, I'll do the same thing. This time I don't have a constant value, but I have 22 I2 plus 10 into I2 minus I1 plus 10 into I2 minus I3 is equal to 0. Okay, so let's go ahead and open these parentheses. And combine the like terms. So if I combine, again, I'll write it in order. So I have minus 10 I1, and I combine the three I2 terms. So I'm going to have plus 42 I2 minus 10 I3 is equal to 0. Okay. So that's my equation number 2. And if I write mesh number 3, I have 10I3 plus 10 into I3 minus I2 plus 5 into I3 minus I1, all equal to 0. You can combine the like terms, which is I3 in this case. So you have 10 plus 10 plus 5, it's 25 I3, and write it in order. So I have minus 5 I1 minus 10 I2 plus 25 I3 equal to 0. Now, I have 3 equations. Okay, by the way, we should label these equations also. This is equation number 2, and this is equation number 3. So from these 3 equations, I should be able to derive my matrix, which is 15 minus 10 minus 5. Then I have minus 10, 42 minus 10. Then I have minus 5, minus 10, and 25. Okay. And since I have 3 currents, so I'll have I1, I2, and I3. And the constant matrix is going to be minus 100, 0, and 0. So any students who are interested in using the MATLAB or calculator technique, then they can enter these 3 matrices into their formulas or the script that they've written for MATLAB, and they should be able to solve for I1, I2, and I3. Once those values are known, you can determine any unknown quantities within that circuit, since all the other values are known. But if you want to go the substitution technique, with 2 equations, 2 unknown, it's a little bit easier to do the substitution, because what you do when you have this simultaneous set of equations, what you do is you determine, since there are 2 unknowns, you derive the value of one unknown quantity in terms of the other one, and then plug it into the other equation and solve for it, and then bring that value back to the original equation and solve for the second unknown value. Since we have 3 equation, 3 unknown, so the technique that is used for that is that you will use 2 equations. So any 2 equations need to be normalized in such a way that you can eliminate one of the variables from it. Okay, so let's say if you combine, if you take equation number 1 and 2, so you let's say you combine equation 1 and 2, and you got rid of, let's say, I3 from there, then you will have to combine the equation that has not been evaluated yet, which is equation number 3, for example, with any one of equations 1 and 2, and eliminate I3 from that also. And what you will do is you will have to do multiplication or whatever you need in order for you to so you'll multiply it by a constant number and to so that they are equal, and then you subtract one equation from the other and you get rid of that term I3. So once you have reduced it to 2 unknowns, then you have 2 equations and 2 unknowns, and using that, then you can proceed by solving it for the two quantities, just like you do it for two equation, two unknown. So you reduce it to that form. Once that is done, then you take these two quantities that you just calculated and plug it into one of the equations to solve for the third quantity, and that's how you are gonna solve this problem. So it's a little bit lengthier process, but again, that's something we have to do if we choose to use this technique. So in this case, I am subtracting equation number, so it's going to be one is going to be multiplied by 2, and I will subtract the second equation from it. And the goal for that is to remove I3. So if I multiply equation number 1 by 2 and subtract equation number 2 from it, I should be able to get rid of I3. And that's not a unique way. You can choose any other values you can combine. For example, you can straight away subtract equation number 3 from 1 also, and you don't need to multiply any quantity by anything, just the I1, essentially I2 is going to be reduced. But then again, if you look at the I2 in any other equation, like the other equation, which is mesh number 2 equation, there's a 42 there. So then again, when you are normalizing it, it's going to be a little bit difficult using that. So you have to determine that which one is the easier technique. So the reason I chose equation 1 and 2 is because I should be able to multiply the equation number 1 by 2 and then subtract equation number 2 from this, and you're going to get the expression without the I3 term. And then if I look at 1 and 5, I could do that. Oh, sorry, 1 and 3, I should be able to solve this also. So let me just show you this, and hopefully it will make some sense. So here what I'm doing is equation number 1 is multiplied by 2, and I'm subtracting equation number 2 from it. Okay. Okay. So if you can actually review the simultaneous equation solving technique, if you're feeling any gaps in this process. So let's go ahead and do that. So equation number 1 multiplied by the number 2. So I have 30 I1 minus 20 I2 minus 10 I3. Okay. And equation number 2 as is minus 10 I1 plus 42 I2 minus 10 I3. Okay. And when we're doing subtraction from it, so this sign becomes positive, this sign becomes negative, this sign becomes positive. Okay. So if I look at this, this term goes to 0. The first one becomes 40 I1 minus 62 I2 is equal to 0. Okay, because the I3 terms is cancelled out now. So now if I were to write it in terms of I1, what I will get from this is 40 I1 is equal to 62 I2, and this could then be written as I1 equal to 62 divided by 40 I2. Okay, so you take this term. So we have, this format. Now we need to get the other equation also where we will plug in this value. So by the way, this is the equation that we're interested in, that we just got. So let's look at the other equation. So I multiplied 5 by equation number 1, and I subtract equation number 3 from it. Okay, so if I multiply equation number 1 by 5, I'm going to get 75I1 minus 70I2 minus it's 75I1 minus 50I2 minus 25I3 is equal to minus 500. So let me just go ahead and write that. And minus 500. And now we are subtracting equation number 3 from this. Equation number 3 is minus 5I1 minus 10I2. Actually, you just have to add because they're both opposite signs here. So we can just simply say we're adding 25 I3 is equal to 0. Take the sum of this. I have 70 I1 minus 15. By the way, this is 50. I apologize. Okay, so minus 60 I2, this becomes 0, is equal to minus 500. Okay, so now these are the two equations. By the way, this is, let's just call this equation number 4, and this one equation number 5. And I derived this value from equation number 4, and then I will plug in this value into equation number 5 and solve for I2 in that way. Okay, so let's go ahead and do that. Okay, so let's do some cancellations here. So the zeros get canceled, or you can solve this, by the way, also. I will use this technique. So now I have 7 multiplied by 62 divided by 4. I'll take my calculator and solve for it. So I got 102, oh, sorry, 108.5 from here, minus 60 I2 is equal to 500. So you can go ahead and solve this. So by the way, there's I2 here also. So I got 48.5 I2 is equal to minus 500, and I2 is equal to minus 500 divided by 48.5. So I can solve for this, and I get So I got 10.3 for this. Let's look at. By the way, there is a slight mistake here. Okay. Okay, so let's correct that. This is gonna be, there's a minus 100 on that side. I didn't realize that. So when you do that, so let's correct. You're gonna get minus 200 here, and so now we have 40I1 equal to 62I2 minus 200, and I can solve for this. So I'll have I1 equal to 62 I2 minus 200 divided by 40. So there's the 200 component was missing from there, and when you're including that, let's go ahead and redo this all. Okay. So now I plug in this value of I1 there. So I have 70 into 62 I2 minus 200 divided by 40, and minus 60 I2 is equal to minus 500. Okay. So 0, 0 gets cancelled, and I can determine these values now. So this is going to be 7 multiplied by 62 divided by 4. It's 108.5. It's 108.5 I2. And then I have 200 divided by 4 multiplied by 7. So if I do 200 divided by 4, it's going to be 50. And times 7 is 350. And I get minus 60 I2 is equal to minus 500. I take this quantity to the other side, 350. So I have 48.5 I2. I combined the 60 and 108.5, and now I can take combine these two. That's 350. So I can solve for I2. So it's 150 divided by 48.5. And it's going to be 3.09 amperes. So that's what I get from here. And then I can plug in this number into this equation here and solve for I1. Okay, so I1 is equal to 62 I2 minus 200 divided by 40. So I1 can then be written as 62 multiplied by 3.09 minus 200 divided by 40. So if I solve this, okay, so it's going to be 0. By the way, this is a negative number. So if I consider that to be a negative number here, they should change the result a little bit. So this becomes 9.79. So now I have values for I1 and I2. I can go ahead and select any one of these equations to determine the value of my I3 now. So if I choose, let's say, equation number 1, which is 15 I1 minus 10 I2 minus 5 I3 is equal to minus 100. And then we'll plug in the two values in there. So I have 15 I1 minus 10 I2 minus 5 I3 is equal to minus 100. And I plug in the two values of I1 and I2 in there to solve for I3. So it's going to be 15 into minus 3.09 minus 10 into, by the way, this is also a negative number. Okay. So minus 9.79 minus 5 I3 is equal to minus 100. Okay. So let's simplify this. So I multiply 15 by 3.09. So I'm going to get 46.35 with a negative sign. So it's going to be minus 46.35. And then this one becomes a positive number. So I have plus 9.79. It's just multiplying it by 10. Minus 5 I3 is equal to minus 100. And by the way, this okay, so we can then say it's minus 5 I3 is equal to minus 100. plus 46.35 minus 97.9. Let's combine these three values. So I have minus 5i3 equal to 151.55 with a negative sign. So I5 here. So I can solve for this is going to be 30.31 amperes. Okay, so let's see if there's any issue there. Looks like all the numbers check. So this is the process. If you have three equations, three unknowns, it's a little bit lengthier process. So I will suggest to use the either the calculator or the MATLAB technique to avoid any errors, because of course there's a lot of substitutions. Sometimes numbers are not straightforward, and then there's a lot of fractions that you're working with and signs are shifting. As you've seen that there's a greater chance of making an error in this calculation. So but you have both the techniques available to you. Either way you can choose that. So you can use the matrix technique, or you can use the this substitution technique using simultaneous equations. Okay, so basically this concludes this session, and I'll use rest of the time if you have any specific questions about the content we have covered during last week and today. So I don't want to start a new topic since we are pretty much at the end of the lecture, and I will start the next topic after the break is over. There are a couple of tasks there's a homework assignment which you should be able to do now, which deals with the node voltage technique. The mesh current would probably be used in so I don't have another assignment for this, but I may have a problem on the exam for the mesh current, just to test that and give you some experience with it. Okay, so any questions, anything you want to talk about, any concerns?
Nope.
Okay, all right. If you don't have any questions, have a happy Thanksgiving and have a great break, and I'll see you on the 6th of December in our next lecture. Okay, have a good evening. Thank you so much.
Okay, thank you.